Okay, we're going to be doing a little bit of the unit conversion problems here, about 3 of them, so it shouldn't take too awfully long. So we've got a patient is given an X-ray exposure of 5.16 times 10 to the minus fifth coulombs per kilogram. Convert this exposure into Roentgens, and we see the conversion factor here. So this one's not too bad. We've got the X-ray exposure, and I'll just call that X. We know that that is equal to 5.16 times 10 to the minus fifth coulombs per kilogram. Now we want to convert that. Now what's our conversion factor? It's this. We want this to be Roentgens. So what I'm going to do is I'm going to say 1 Roentgen is equal to 2.58 times 10 to the minus fourth coulombs per kilogram. Now what's going to happen here? The coulombs per kilogram are going to cancel. That leaves us with Roentgens. So now we've got 5.16 over 2.58. So weird looking 5, but there we are. Times 10 to the minus fifth over 10 to the minus fourth. So, and then at the end here, we'll have Roentgens. So now, let's see, if we have 10 to the minus fifth here and 10 to the minus fourth, essentially, another way of looking at this is 5.16 divided by 2.58 times 10 to the fourth over 10 to the fifth. That cancels with everything except for 110 here. So we've got 5.16 divided by 2.58. So what does that end up equaling? Well, if I take 5.16 divided by 2.58, that's 2. So if I go back here, start writing this again, I get 2 divided by 10. Got to remember that 10 there. Roentgens, which is 0.2 Roentgens. Okay. That's the first problem. Scroll down here. Let's go to the second problem. Young therapist. I don't know why a non-young therapist can't do this either, but a young therapist with a mass of 75 kilograms at an affiliate in OKC is in an endurance trial, and he ran from the basement to the 7th floor, which is a height of 28.5 meters, in 23.6 seconds. We're just going to assume that they could run it in a straight line up. Can't be done, but if we could do it, this person could do it. So calculate the work done and the power generated. All right, so let's take a look here. So what is the work done? We know that the work is going to be equal to force times the distance. What force needs to be applied here? Well, we've got to take 75 kilograms and we have to move that against an acceleration of 9.8 meters per second square. So let's figure out what that is. $75 times 9.8, 735. So we have 735 kilogram meters per second squared. So that's 735 newtons. Now, what's the distance? Well, the distance is going to be 28.5 meters. So we've got 735 times 28.5. Oops. So it's 2947.5. Newton meters or joules. Power is basically going to be the amount of work divided by the rate at which it's done. So we've got 20,947, which I seem to remember here to keep that straight. And that is divided by 23.6 seconds. So if I take the answer here and divide it by 23.6, 887.6. And that is in watts. Okay. So let's take a look at the final one here. 86.25 gray is equal to how many centigrade? And then how many rads? So let's see what we got here. We have 86.25 gray. How do we convert that to centigrade? Well, we have to know how many centigrade are in a gray. Since we're looking to cancel out the grays, I'm going to put that down there. And there are, in fact, 100 centigrade in a gray. So 86.25 times 100 centigrade, because the grays cancel. So you come up with, well, buzzard. Let's try this again. $86.25 centigrade. How many rads is that? Well, as it turns out, if you look up the conversion factor, you find out that 1 rad is the same as 1 centigrade. So centigrades cancel. Multiplying it by 1. That's what you've got. Okay. Not bad. Not bad stuff at all.